Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and today I'm going to talk about, I guess I still haven't decided on what the title is of this video, whether it's going to be collecting energy at right angles, the Heaviside component, or just really the collection of energy. But I want to go over a few things that are really important, and again, I want to try and point people in a direction, give them some pointers, and help them along the way where I can. There's always so much information. I'm trying to simplify it in a way that's not too technical and that the average person can do. That's really the point of my work, is not to change the academia as much as to help the common man and woman, common person. So what I have here today is a couple of things. First of all, you might have heard, if you studied any of this, about the Heaviside component that Tom Bearden brings up frequently. And we hear about negative resistances, and we hear Tesla and talking about collecting energy at right angles. And what does all that mean? How can we make sense of that? So I want to go over some of that today. I'm not going to be able to exhaust anything or even probably say it correctly, but I'm going to steer you in some directions where you can learn yourself. So we're going to begin. We're going to look at an article or a journal technical paper from Tom Bearden from 2008 of August on extracting electromagnetic energy from the vacuum. Now, I'm only going to read a couple of paragraphs here and there and go over that, and then we'll look at some of these diagrams while we go over these. So at first, what I want to do is just start your engines. Let's turn on this little motor here. Before we get into it, I should just... So this charging battery right here is at 1230. And this is one of my little motor kits that I've sold for, about 8 years, 7 years now or so. And you know, if you don't know anything about this, I'll just briefly explain it, that it's a motor that runs as a motor and it charges up a battery at the same time. Does it have any significant power? Yeah, it does. It's not our most efficient motor or most powerful motor, but it will do something. So this is going to be kind of like a little bit of a joke that I do at my meetings, where we have this extremely high powerful generator here. No, it's just a little tiny generator with an LED, and we're just going to run it. I actually started Renaissance Charge with with somebody else who actually owned, you know, these really big wind generator system. You know, this $2 million wind generator. And I used to joke and say, well, why don't you bring that indoors and we'll drive it with one of our motors. And that was a big laughing point. But anyway, let's look at this. Let's turn it in the right direction. Oops. So you can see that it is moving a fan, and it is speeding up, running this LED, and of course it's charging this battery pretty quickly. Now, what I usually do in my meetings is I run this the whole time, and I usually have my other generator coils powering some 3-watt lights at the same time, and then I switch around the batteries and just have it running continuously. So anybody who's come to my meetings has usually seen this, and I put this in a glass case or a plastic case many times. But today we're going to do something a little bit different. Today we're going to look at let's just hold off on that and wonder what happens if we only receive part of the airflow. So what if you miss the majority of the airflow, and then you go around telling everybody that's all you can get out of it? So we'll look at some of these bigger fans in a minute. I don't want to leave that on so that you can't hear me properly at this time. We don't need to demonstrate this as a motor. I just wanted you to look at that and consider the airstream here and only collecting a little bit of that airstream while the majority goes past, because that's what we're going to talk about today. So we'll get into running the other fans, and I'll explain more of them in due time. But let's go over the beginning of this, the abstract of this Bearden article. Now let me just say a bit about Bearden. I am not going to endorse him as a person or all the things that he has said and done. I've been in his home twice, and I guess I considered him a friend for many years. I'm all over his website apparently still, but I disagree with him in many matters. So I don't want to read this and say that I'm siding with Bearden and anything he has said or done or taught, because in fact I don't want to agree necessarily with everything said in this article. But there are some things that are really interesting, and I think we can look at them and consider them. And so, saying that, let's go into it. He starts off with, generators and batteries do not furnish any of their internal energy to their external circuit. What? But only dissipate it internally to perform their own work. To perform work on their own internal charges to form a source dipole. Now I've said this for years, and it doesn't make sense in your mind when you think it's just the opposite. And that's why I've said that the battery in a closed loop circuit is only discharging itself. And it's a waste. And so I've been showing different teachings on the subject, show you how to not even close the circuit, which is when we get into Tesla one-wire circuits, which we'll look at here. Oops. I did print up another one here somewhere. Oh, right here. And we talked about that in one of the last videos, where we actually don't have to have a return circuit. And it's something that's hard to even wrap your brain around. if you've been, working in these various fields with the closed loop circuit. For me, it's very difficult. Even though I can see it clearly and experience it, even when I do that, I still live in this world in which we have closed loop circuits all the time, and we're always destroying more than half the energy in the process. And so you're so used to seeing that and doing that, even if you can do otherwise, it's still hard. So somebody who doesn't even believe it or has never experienced that, it'd be even more hard to even begin to consider. But that's the opening statement here. And going down a bit, he says, the tiny Poynting fraction intercepted by the surface charges enters the circuit to power it, while the huge non-intercepted Heaviside fraction misses the circuit and is wasted. So this is what we're going to talk about today a little bit. And I'm going to quote from Heaviside in a minute. But what is he saying? What is he saying in that? He said that, so if you had a wire, you had the power going down the wire, the circuit, right? That only a fraction of the energy that is flowing gets actually intercepted by the wire in all of our circuitry over the last 140 years. And this is what we have conveniently, what I'm going to be reading here, I'm just summarizing, what we have been conveniently using in our constant current closed loop circuitry is a very simplified method of destroying the energy wastefully and only collecting a little bit, just enough to make it still somewhat practical, enough that you can charge money for selling power. It's a genius way of actually making a pretty simple system in which you can sell power and not really reveal the things I'm talking about today. So, now, if we look at this airflow in relation to this wire, so if you look at the real flow of energy that is being produced, or not even produced, being directed, because we're not talking about creating energy out of thin air. We're talking about tapping into what's already around us, like breathing air. So when you're breathing, you're not creating the air, right? You're just using it. And you're kind of just cycling it in all these chemical reactions. Oxygen in, carbon dioxide out, blah, blah, blah. And so, really, if we want to look at it the same way, the generator and the battery aren't creating the energy. It's not coming from them. When you actually think about it and look at the physics and all that, you realize you can't. And that's what this article is all about. I'm not going to get into all the real technical side of it. I'm just going to go over that basics and just try and paint a picture. Because that's what's needed, to get beyond all these words and just demonstrate it, see it, and begin to think. Because it's not even about demonstrating it. It's about actually visualizing it and coming to grips with it. Like, even though you can see it, it's hard still to come to grips with it, even with me after all these years. So anyway, what is Poynting and Heaviside? What was their point? So let's get into this. So any EM system may be asymmetrically re-gauged freely, changing the energy of the system by changing its potential. Now that might be a little hard for people to understand, and you can read the whole article and contemplate that statement in your own time. Well, let's get on with it. By placing the source dipole, so a source dipole is like a battery, for example, is something where energy, like a magnet, where energy is coming out of. It's a source, it's got a positive and negative. So by placing this source dipole in a closed loop with external loads, so we're looking at external load being this motor here to this particular battery. So we have external loads and losses. Half of the free excitation energy is then discharged by the circuit, which destroys the source dipole, while half powers the loads and losses. And this is what we've talked about in this series on loving paths, selfish circuits and loving paths, and how to have less losses and create floating grounds like we're doing here, where it's not part of the circuit. It becomes an open loop, both a closed loop and an open loop here, because we're charging the battery, in this case a bigger battery, at the rate that this is discharging. And we can do a whole bunch of different things. But normally, we're just wasting. So we're going to look at one of these fans here, this one in particular, where I've shown this in a video, where we've simply removed one diode, flyback diode, and added two more in a different location on the collector of the transistors, and we come out charging a battery and running this at the same speed and charging a battery now instead of not doing anything with that energy. And so we'll run this in a minute, and there's a generator on it as well that we put right on the fan to have an output instead of just the airflow. But anyway, but normally, like I said, we just discharge the battery in a real hurry, and then we have to pay to charge it up. So what is that process that was became the way? It was called Lorentz symmetrical regauging. So that additional internal generator battery must be made available to dissipate on the internal charges to reform the dipole. So in other words, it's just as fast as you're running your load, you're discharging your own battery by reconnecting it in a closed loop. So if we have a source of power and we run it, we tap into that source in a way that doesn't short it out, then it won't discharge. It will remain. And we can see a lot of these things in the creation that are like that. But when man tries to do something better or contrary to the creation, what happens is he messes it up. And that's what we are doing. We're doing something that's unhealthy as well. Anyway, the total energy flow in space surrounding the conductors has two components as follows, according to Bearden. Now, again, I don't want to try and come across like these are the correct words that should be used about these processes. or there's only two, only two components, as he's saying here. I don't have the ability to judge that, but I'm able to experiment with these things and see that they're not we're not limited to what we normally experience with a closed loop circuit. So, having said that, there's according to Bearden, two components. There's a tiny pointing component of energy flow directly along the surface of the conductor. It strikes the surface charges and is deviated into the conductors to power the circuit. So in other words, it's not coming from what you think is the source and going around and completing the circuit. It's simply that when you connect it up in a closed loop circuit, the battery is discharging itself, and all this energy that's flowing in, only a little bit is coming into the circuit. Just enough to make it worthwhile. Otherwise we wouldn't do it at all. If we really saw it the way it was flowing, like if you could actually see this flow, you'd be like, well, that's ridiculous. Why are we doing that? Why are we destroying the source? Everybody's like, how do we get away from not doing that? Well, listen to what I've been talking about, and you'll see. So, number 2. Then there's a huge non-divert Heaviside component. So let's look at this airflow, right? And all we were doing is having our collector, like at the bottom here, only collecting a little bit of the airflow instead of the whole thing. I mean, how would we go, like, let me ask you right now, early on in this video, how else would you do it? It's pretty basic geometry here. So think about that, and we'll get to that in a minute. So this huge Heaviside component is filling all space around the circuit. This is the circuit entirely, and is wasted in all those circuits using only a single pass of energy flow. The Heaviside energy flow can furnish energy to the circuit if retroflected to again pass over the surface charges. But conventional power systems completely ignore this enormous energy source accompanying every circuit. But it wasn't so way back at the beginning, before it was all standardized and the experts told us our limits. So, footnote number 3, he says, Poynting Heaviside independently discovered the flow of energy through space. C.J.H. Poynting on the transfer of energy in the electromagnetic field. Philosophical Transactions of the Royal Society of London, Volume 175, Part 2, 1885, page number 343 to 361. And then Oliver Heaviside, Electromagnetic Induction and its Propagation in The Electrician, 1885, same year, 1886, 1887, and later, Electrical Papers, Volume 2, 1887, which I have here, page 94, and then 405 and 514, on the forces, stresses, and fluxes of energy in the electromagnetic field. Philosophical Trans Royal Society, London, 183A, 1893, page 423 to 480. So Poynting erroneously considered only that the energy flow component entering the circuit, and completely missed the huge additional component shown by Heaviside that missed the circuit. Hence, Poynting got the direction of the energy flow in air by essentially 90 degrees. It was later corrected by Heaviside. In this paper, we call the neglected non-divergent component of energy flow the Heaviside component. Now, I'm not saying that that's correct. I don't know, but I do know you can collect a whole lot more energy. However it exactly happens is debatable. That you can do that is, I know from experience that I can do that. You might not know that, and that's fine. I don't expect you to believe that, but who's anybody to say what you can and cannot do in the sense of what's physically possible? And that's where you have to say, says who? There's enough testimony should make you think about it. Anyway, footnote number 5. So Heaviside realized both the diverged, intercepted, and non-diverged, non-intercepted components of the energy flow associated with the circuit. He corrected Poynting on the direction and obviously pointed out that the amount diverged into the circuit, the Poynting component, was tiny compared to the amount non-diverged, which we have occasion to call Heaviside component. So see these papers. Now, instead of quoting it here, I'm going to read, because I typed this, or I got this reference off of Google Books, and then what I do a lot of times is I format these old writings, especially around this time period. I've done hundreds, over 1,000 different articles and books over the last 26 years in philosophy, theology, and now electrical. And so what I did is I put this onto a document file, but I can't get all the equations and illustrations in here. So I'll probably put it on my potentialtech.com website for people to see, and I'll put the links there. Anyway, I read through this whole chapter. It's section 35 from the electrical papers, as I cited here, page 1887, page 91 to 97. So it's the transfer of energy and its application to wires, energy current. And he says some interesting things, starting off with that he was a materialist and says there are only two things going, matter and energy, in his opening paragraph. Nothing else is a thing at all. All the rest are moonshine, considered as things. Now, I don't agree with that, but again, that could be a play on words. He was manifestly a materialist, but that had different kinds of meanings back then. I don't want to get into that. So I'm not saying that I agree with Heaviside and his reformulation of Maxwell's equations either. And it's not my purpose to get into any of that, only just to bring up, you know, when this was really first brought up, who brought it up, and that it does play a major part in this whole discussion. So a couple of points here. I just want to read quickly on page 91. He says, I'm not going to read through the whole thing. I just want to point out a few things, and you can read it over on your own to get the full context. So the transfer from place to place can be, in great measure, traced so far as quantity and time are concerned, but it does not seem possible to definitely follow the motion of an atom of energy, so to speak, or to give a fixed individuality to any definite quantity of energy. So this is where he's starting to, like, everyone wants to quantify energy, they want to explain it in its essence, and I don't even believe that we'll be able to do that in this life. I think we don't really have the ability to so perceive the nature of everything, and we have to be content with that. And a lot of people speculate with all their theories, but here he is basically admitting that. Later on, he brings some examples, and he says, where the energy came from is here left unspecified. Again, though what the potential energy may be, and whether or not is kinetic or partly kinetic, we are not able to decide. So again, these are the kinds of things that he's admitting and saying, hey, let's get real here. We can say these things, but we understand the effects of energy, but what is it in itself? Where is it really coming from? We don't know. And believe me, we're no better off today. We're worse off in our understanding. Oh. So much for my highlights here. Alright, so what I'm going to do... Oh no, here we are. So he goes on, and I don't want to read this and throw people off by getting too technical. It's not really technical until the end of the chapter, but the relevant point is he's talking about an energy flow here, which is with the capital W, I believe he's saying. But anyway, he starts off with this second last paragraph on page 94 now. He says, a general description of the transfer along a straight wire was given in section 2, volume 1, page 434. Alright, so we're talking about this flow of energy. So it takes place, now the whole complete flow, that he's trying to account for the whole process of what's happening without knowing where it's really coming from, how it's really doing it, but that there is this flow happening, right? It says it takes place in the vicinity of the wire. Right, where's my wire? Okay. Right? Somewhere in the vicinity of this wire, obviously. Very nearly parallel to it. Parallel, right? With a slight slope towards the wire. Right? So this is where we're going to get this diagram from Bearden. This is the total flow. So we look at this like a fan blowing this air, and just a little bit is catching on the wire, while the majority of it, supposedly billions of times more of the energy is flowing on past. So it was described in that thing. So Poynting, on the other hand, now he's criticizing, holds a different view in the Royal Society Transactions, February 12th, 1885. Holds a different view, representing the transfer as nearly perpendicular to the wire. The fan is blowing this way, right? Right? I.e. with a slight departure from the vertical. Just a little bit. This difference of a quadrant can, I think, only arise from what seems to be a misconception on his part as to the nature of the electric field in the vicinity of a wire supporting electric current. So he's mixing up the two things that are going on. He's mixing up the effect with the actual source flow. And that's the way we're looking at it. This little magical fairy ball, electron, is going through this loop. And that's it. Or it's coming from external, or maybe one way or another, or I don't want to sound confused, I'm just kind of mocking the theory. And it doesn't make sense, it's contradictory. So he's showing and saying how that's not the case. That it actually is flowing parallel to the circuit in the direction of the current or the circuit, and not, this energy is not coming in perpendicularly or slightly off vertically. Now, the lines of electric force are nearly perpendicular to the wire, right? The electric force. The departure from perpendicularity is usually so small that I've sometimes spoken of them as being perpendicular to it, as if they practically are, before I recognize the great physical importance of a slight departure. It causes convergence of energy into the wire. So then he goes on and goes over to page 95. To estimate the amount of departure, we may compare the normal and the tangential components of electric force. Let there be a steady current in a straight wire, and the fall potential from the beginning to end, blah, 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 blah. And he goes on. I don't want to get sidetracked from the point. So it is clear at once that there is an exceedingly small fraction of the normal component of electric force. If the wire be long, and that it is only under quite exceptional circumstances anything but a small fraction, Professor Poynting should therefore, I think, make his tubes displacement stick nearly straight up as they travel along the wire, instead of having them nearly horizontal, unless I have misunderstood him. So, think about it. You got this wire, and you're testing out the flow, and if you're only testing in this direction, when the flow is in the same direction, you're only going to get a little bit of this diverged. But if you actually test it perpendicular, then you'll notice a whole lot more of this flow, which is what Heaviside figured out. So, enough with that paper. But there you have the first admission. But where did it go from there? Did anybody do anything with it? But it was quickly discarded or ignored, and therefore we have what we have today. I mean, there it is historically. So let's go back to Bearden, and he says why Lorentz eliminated the Heaviside flow component. Lorentz, right? The Heaviside component was arbitrarily discarded by H.A. Lorentz, who integrated the energy flow vector itself around a closed surface encompassing any volumetric element of interest. This discards any non-diverged energy flow components, regardless of how large, and retains only the diverged component. So only that little bit that went in is only considered practical for their mathematical solutions and for their economic business, right? So effectively, Lorentz arbitrarily changed the energy flow vector into its diverted flow component vector. So a fundamental non sequitur. In one stroke, he discarded the bothersome Heaviside component, reasoning that it was physically insignificant because in single pass circuits, it does not enter the circuit and power it. This is rather like arguing that all wind on the ocean that does not strike the sails of a single sailboat is physically insignificant. So it'd be like me moving this fan this way or up here and only getting a little tip of it and then saying, well, it's not really that powerful, it's not really significant. Or having a very little wind generator like this and putting it outside and not realizing that you could have bigger ones and more powerful ones, and saying, well, it's not really worth it to do that because you only get so little out of it, right? And that's kind of true, that the cost of, you know, setting up a big pole and all that, and, or cost of solar panels is not really worth, mostly the cost of the batteries is not really worth to do solar, right? And that's exactly why I'm all in this business in the first place, is because solar and batteries dying were the biggest problem in having alternative energy. So I solved the battery restoration longevity issue, and then also the battery or the efficiency issue, and that's why I'm in this whole work. But anyway, that's what he's saying. It's like taking, well, I'll get into running the fan a little bit later. So a moment's reflection shows that the insignificant remaining wind can power a large number of additional sailing vessels. A very large amount of energy can be extracted to do work if that physically insignificant wind is intercepted by additional sails. So you've got to put something there. If you don't even have anything there, then you can't call it insignificant if you don't even try it out. But if you don't know what to do, if you run everything just like everybody else does, if you live in a little black box and you never open the door and look outside, then how do you know? For example, you can laugh at these things, but if I can charge 1 or 2 or 3 batteries at the rate of 1 battery discharging, forget about the motor, I've already have more power in my batteries. But if I can actually run the motor and keep switching my batteries around, then it's certainly something to consider. It's not insignificant. So to summarize, the intercepted Poynting energy flow component freely excites the external circuit, right? Somehow I lost my wire. Oh. So it excites this wire, right? Just a little bit, just enough to satisfy you, right? Because nothing in life's for free, right? Anyway, just enough to excite the external circuit, which then will decay from its excited state and release its excitation energy back into its vacuum environment, as he uses the word vacuum. Due to the design of the closed current loop circuit, that decay is self-enforced to be symmetrically regaging of the system back to the non-excited state. In present closed loop circuits, half of the Poynting excitation energy is still used in this symmetrical decay to destroy the source dipole. Other half of the Poynting excitation energy is used to power the loads and losses, so that only a part of that half is dissipated in the load. A real circuit has losses, so less energy is dissipated in the load than is dissipated to kill the dipole. Since it requires at least as much energy to recreate the dipole as to destroy it. Then the energy continually dissipated in the load is less than the energy we have to continuously input to the shaft of a generator to recreate the dipole. For systems with such a self-defeating circuit design, we cannot obtain as much work in the load as the energy we have to input to keep restoring the dipole that our circuit diabolically keeps killing. So conventional circuits exhibit COP less than 1 by design. All right, so again, the small amount, I'm just reading, jumping around in this article here. The small amount of water diverged from a river's flow around a small fixed pebble on the bottom is most certainly not the magnitude of the river itself. A tiny whirlpool in a river is not the river itself. So think of those analogies. Think of this fan, airflow, river flow, and realize, or at least consider, that there's a lot more energy flow available if you just learn how to tap into it. Like I said, and we're going to get to that in a second, there's three or four essential stages to any kind of over unity system. One being the creation of the pulsing, and then the collection of the energy, and then the transformation, utilization of it. So we have to figure out the collection the right way. So the very definitions of field and potential have been corrupted in conventional electrodynamics to only include their Poynting intercepted and divergent energy flow component. So notice the definitions are stacked, and that's across our whole culture. All the definitions have been dumbed down of words. That's including in theology, in religion, and all sorts of things. Our food has been dumbed down until it's no longer food at all. It's not nutritious. All these things have happened over time. And so this is the beginning of where this happened. That's what this video is about. So they've been dumbed down, they have been changed the definitions to only include this one element of energy flow component, and to discard their enormous Heaviside non-diverged energy flow component. And so it's a play with words. It's a sleight of hand to get you to say, so here's the big circle, and we're only going to focus on the tiny corner of that circle and say, now this is all that matters. So that's what you got to think logically. You're still telling a partial truth that it is the energy flow, and you can deceive everybody by changing your definitions to say, well, it's like a tricky lawyer saying, well, yeah, technically I'm saying the truth. Technically, I'm talking about really the way we're using our energy right now, and that's the way we're using it, so therefore that's all that we can expect, and that's all there is. I'm not really saying that there couldn't be more, we're just not doing it. It's a play on words. It's a redefinition of the words. But nevertheless, it's there, and it can be tapped. A priori, or beforehand, classical electrodynamics CEM does not calculate the field or the potential, but only a tiny Poynting-based component of each. Precisely that tiny portion diverged around an arbitrarily assumed unit point static charge. CEM calculates the reaction across section only for a stationary intercepting diverging static particle. The actual reaction cross-section will be changed. Example, for a resonant non-stationary particle. So when we're getting things in resonance, suddenly, well, now we've got a violation of the rule, right? This is where Ohm's law doesn't apply suddenly, right? So without any change in the true field or potential, there's nothing changing to the input in the system, But suddenly under the situation of resonance, suddenly something different is happening, which really violates these laws, which is exposing the fact that there is more energy available. Just like what we're doing here, instead of, even without running in resonance, we have an additional manifestation of energy here. And it's beyond doubt. It's very easy to show this, very simple. And so we have this extra energy that it can be accounted for if you go back to these original papers and understand that, just like in resonance. So he's talking about resonance here. I want to finish that. The resonant particle will therefore seem to collect and output more energy than that was actually put into it, as shown by Born and others, and is shown by these things, of course. It collects the additional energy from the neglected Heaviside energy flow component, unwittingly input by the researchers, but not accounted by them. So there's all these, examples of negative resistance and violations that they have to account for by new exceptional laws. But it's already always there. And I've shown that, where we can take anything and modify it to demonstrate that. The energy is there if you collect it. So essentially, what you're going to understand, if you really pay attention to this teaching, is that you can still run everything exactly the same, but you can still collect a lot more energy at the same time without affecting the operation. Like when I run this motor, the normal way it was made, or just by changing the one component, or just replacing it actually, to another part of the circuit, I can now run this motor exactly the same speed for the exact same amount of input energy. I can still discharge my input battery, but yet I can charge another battery at the same time, like significantly. Now if I make further modifications that make it more improved, I can actually charge the battery at the rate that the battery is discharging. Or I can have bigger batteries and I can charge 200, 5,000 times more output than input, depending on how big of a battery bank I want to put on it. Or adding more and more processes. There's no limit. There isn't. Because it literally is many more times output. But anyways, the point is, on this particular circuit system here that we use in the motors, it's called negative energy, even on Wikipedia, the absolute source of all truth, right? They even use those terms. It's a negative energy flow that is not normally used. So whether we're looking at resonance systems and the violation of Ohm's laws and all these related ideas, or a means of having a open loop floating ground system where we're capturing that energy rather than just using the suppression system, the snubber system that merely suppresses this spike, right? So anyway, coming down to it, the problem is in collecting and using the enormous energy easily extracted from the vacuum, not in simply producing the direct Heaviside electromagnetic energy flows. In other words, the flow is always happening, but now how do you collect it? And that's the various types of geometries and circuitries that people have been playing with for the last 150 years, from the earliest days, where they were not defining the terms to ignore any phenomena, but they were readily using the phenomena before it became standardized, before there was a utility built. and schools to support the whole ignorance and deception. So, in short, the problem is how to obtain much more Poynting energy from the easily available enormous Heaviside energy. One can build one can build a vacuum energy extractor for less than $1. So this is his example, and I'll probably show a link of the diagram that he has. Simply place a charged capacitor. So here we have a 4,000 watt capacitor we're going to look at in a minute. Or sorry, 4,000 volt capacitor, very dangerous. And here we have a 2,000 volt, 100 or 1,000 microfarad capacitor. And place a charged capacitor or electret. Now electret will give off power. Placing this capacitor, charged capacitor, upon a permanent magnet so that the E field of the capacitor is at right angles to the H field of the magnet. And the energy flow from the magnet is maximized, a function of E times H. So that's an interesting experiment, and that's really the only, he gives like 14 with all these 14 points and all these sub-points of examples of being able to extract energy in various ways. And a good number of them I've been able to experiment with and confirm in this paper here. But this is one that he specifically says that can be demonstrated. So the system will extract energy from the vacuum and steadily output it indefinitely as a Heaviside energy flow. It does, however, sharply focus attention on the real problem of how to collect and use some of the energy from the balanced vacuum energy circulations set up by the system between the local vacuum and the distant non-local vacuum. Now, like I said, I'm not big on using the word vacuum, you know, the whole idea of ether and vacuum and all the different theories, but this is his understanding. And I don't want you to miss the point, which is that it's one thing to create this flow, but it's another thing to tap into it. And so the easiest way to do that, or the only real way, is I shouldn't say the only way, but the only real practical way is to get a decent amount of collection is through a pulsed system. The faster, the more repeatable the process is, and therefore, like, the faster you collect the water from the ocean from your cup, the more you're going to get, right? So the higher the frequency. So again, the problem is how to convert the Heaviside energy flow to Poynting energy flow. So he's already given you, we talked about from the beginning, the energy is flowing parallel slightly into the circuit. So collection should be what? Parallel? That's what we've been doing. Perpendicular. Wonder what this was about in my last video. So again, once the vacuum energy transducer, is what he's calling it, the generator's source dipole is in place, is another matter to intercept, collect it, and use the modified local vacuum circulation energy pouring from the transducer to power loads, and to do so without destroying the source itself, the source dipole created in the collecting generator. So unfortunately, our power scientists and engineers have been focusing upon the wrong end of the problem. And as Poynting was off 90 degrees. So let's go into the actual let's clearly get into some of these things. So let's so of course we only ran it for a very short time and it went up maybe a couple of tenths of a volt or whatever it did in the short time we were charging it. So let's go now and look at another, oops. Let's just finish the illustrations I have here. So we'll start with this fan. This is one that's been around for years. Hook up our charging battery first, because it will blow out the circuit fairly easy without any kind of protections on it. And that's why they short out, or that's one of the reasons why they run the circuits the way they do, because they don't want to deal with that pulsing that destroys the circuit very easily. So let's do this analogy again. So here's a fan, right? So we have airflow. So now, if we go in the direction of the flow, we can get a little bit of energy, right? And there's the light. I think it's lighting up, maybe. So this pointing flow is not very much, but if we look at the whole picture, or actually, we're going backwards. Sorry, this fan can go either way. I spun it the wrong way. It was actually sucking the air backwards. I was like, boy, that's really not putting very much out for. Like this should easily be able to turn. I was like, what? I was like, why isn't that spinning faster? Because I was going backwards. So anyway, if we talk about this the same way, look, if we go up here, this is what we're doing in our circuits. We're just barely going like this. We're saying that's it, that's all you get. Let's write the book and just say you only get a trickle. But suddenly we go into resonance and whoa, well that's well, let's not talk about that, or that's exceptional, that's only sometimes, right? And don't think that you could do two of these now. Don't you dare do parallel resonance and series resonance, and no, don't go there. So anyway, that is my little one motor, and that's kind of my illustration. I want it to stick in your head for good. I want you to think about that, because it's just necessary to get beyond these books, and so we can look at the charge of this battery, which definitely would have been charging up. If I could straddle this big huge voltmeter. So we're at 1257. So I charged it up. And of course, to discharge these batteries, this is not, I mean, it is partly self-charging. Some of the energy goes back to charge the input, but not purposely in that basic circuit. So here's the one, just to show you. I always forget which one's the charging battery, which one's the input. Now I'm just going to charge at 12 volts. I think this was the charging battery, I'm assuming. We'll know in a second. Yeah. So this is actually a 48 volt motor. I'm only running it at 24 here. So it's not the right. Anyway, not that that's not important, but it does charge the battery. And that's not really what the focus of this video is about, but I just wanted to show that. Again, the battery will be shown to have 1283. It's coming down after, you know. So enough with that. Now, let's look at some more detail. So why was it that I brought this thing out last time and somebody else way back did demonstration? People were like, well, what does that do for me? Well, it really teaches you about this whole flow, the right angles. So what is this? What are these? Copper, aluminum, and plexiglass in between. A little bit too thick for what I'm wanting to do, but nevertheless. So let's look at well, first of all, the negative resistor. So a battery is usually a source where the energy, it's a source of energy which supposedly provides power to a resistor, and the energy dissipates out from the resistor, and in the battery the energy comes into the battery. But a negative resistor powers a resistor, so the energy still goes out of the resistor, and the energy comes in to this negative resistance. So in this case, the battery in that example that I just showed with the motors becomes a negative resistor. The energy flows in. It has everything to do with what we're talking about in here, because we are maybe directing this energy into the battery in a way that's not normally done. So that's just, one passing note I wanted to make. So let's look at a little bit more before we go into the demonstrations here. So here's a paper that you'll see, I'll put it up, a diagram showing Lorenz's surface integration and the difference of directions, parallel, perpendicular, and it's as simple as that. It's a sleight of hand of just 90 degrees wrong angle. So it's the S vector, and he goes into that. You can look at the diagram. And here is another diagram of energy flow contours surrounding a transmission line. So you have this energy, huge Heaviside component misses the circuit and is not intercepted, is wasted energy. It's all there. And you can, well, you can tap into it. So only the tiny sheath pointane component strikes the surface charges and is diverged into the conductors to power the circuit. And so all of our meters are set up to only detect the one component. And so it's a big circle. So what you go in with is what you come out with, right? Now, so we looked at recently the Tesla one-wire circuits, and he said you could run any load, and I don't really want to get into this too much because I don't want to distract from what we're doing, but I just want to remind you that you can run all loads with one wire, with high frequency circuits and preferably high voltage and above 20 kilohertz. And so you can still do it lower like we're doing in our motors, and what I call the third stage process, where we're essentially doing this sort of thing where if I have a resonant series circuit, I can multiply it out with no losses. I can have continuous resonant series circuits and have a continuous output from going into my charging battery. And I've done it even without being in resonance quite a bit. Like, in other words, I can put many series loads in series across the one wire and do all these kinds of experiments, and that's at low frequency. And Tesla talks about that in that lecture, the one wire lecture, where he says, you know, the iron component in a motor system really prevents resonance, but the sudden discharge of a motor, of an inductor, boom, even at lower frequencies still can accomplish similar things. So that's why we're doing it on the motors effectively. But anyway, if you kind of look at this, these are at right angles too. These are nodes at right angles with the transmission line. And in a way you could look at this as almost in a sense collecting the regularly non-diverged energy, because you don't have the closed circuit. So you have all these other potentials, and you notice the P plate, as we talked about in these videos, the P plate being a suspended piece of metal, or the ground itself. So like here you can see it's suspended. And so you can collect a lot more energy with these various ways. So I'm not going to get into that too much, but that it is obviously in every way more efficient than a two-wire system or a closed-loop system. There is no need for losses in such a system. Now, I'm not going to oversimplify that. There are several things involved, and there were several things he was teaching about in that lecture, and it wasn't primarily to teach how efficient it was just simply to say, hey, it saves you money. Like for example, transferring power from power station, you have to go from the main distribution point to the substations, and you have to pump up the energy periodically to keep it all flowing. But if you had that kind of system, you wouldn't have those losses, and you wouldn't have to worry about just in the energy transmission alone. And you would also not have to deal with the lagging time, and that's just another whole mess. Now, there's another thing here, and it's a very hard thing to look at in even the original paper on Tesla's wireless system in one of these articles here. But there's 4 different ways of running his circuits here. Which I showed you some there, but he shows them perpendicular. So here he has, his circuit, like a tank circuit, running perpendicular to this big copper bus bar, and then he has another one running parallel. So there was another, I think, a resistance or inductor with a capacitor, and then he has one well, one of them's embedded, this one's embedded, and this one is on the surface. That's right. So these are 4 different ways of running these circuits with a high frequency pulsation. And so they are going to also collect this energy flow, more or less. I mean, it's not so much about what we're talking about today, but I just wanted to draw attention to it again. Anyway, so there is actually a patent. Don Smith has, in his book, this dipole transformer generator. And so you can see he's got a dipole here, and the ideal material is really expensive, magnetostrictive material, which you can use various things, but so he's running a high frequency coil and a dipole that oscillates really fast. The faster the better. And he puts these capacitor plates perpendicular, right, to the dipole. So if I have this dipole here, right, actually make sure I turn off my voltmeter and take it away when I do any of this. So if this was going through it, right, on the center, then we would have his system here. And the pulsing can go back and forth with each oscillation internally. The secondary coil is open here, right? There's actually 2 coils. There's a transformer and then another, there's 2 transformers in here. And, well, it's induction coil here because it's got a spark gap interrupter. And then here it's got another transformer with open secondary. And it comes out. So it's high voltage and high frequency. And so you would have that going through there. So if the flow is going in this direction across the circuit, right, so to speak, this is the flow. So the arrows, so if we have that like this, there's the Heaviside component. There's the flow in that direction. So, what should we do? Maybe put a net up and catch the air. Like, look at this as a big collector, right? This isn't new, guys. This has been out there for, what, 20 years now, is it? What, 90s? Yeah. And it's very simple. So he has, so let's just do it. So I can only do it very short because what I have is on either side these high voltage wires going to a high voltage bridge, the high voltage capacitor. And I was really stupid enough to check the voltage. I didn't actually think it would charge up as fast as it did, and I blew up my expensive voltmeter. So I pulled out this old analog voltmeter just for that kind of old feel, like we're talking about these old processes and these old writers from the way back, and these are the kinds of things that they had back then. So this one's 20,000 volts voltmeter, and it's hooked up for DC electrostatic type. So right now we've calibrated that to be at 0. And so what we're going to do is just turn this on. This is called a violet ray device, and I've explained it. And actually we'll start off by using the tube. We could actually just use the tube. So if I turn all the lights off, you would see a violet color. Right, so we could probably, we've already started charging this capacitor just by being in this vicinity. Now there's not as much coming out because what's happening is this is seeking a ground. It's seeking either an air ground or any kind of ground. So if you turn out the lights and you open this coil up, you would see it just like, you know, like this is a Tesla coil, which is not even really a Tesla coil, it predates Tesla a bit. But anyway, it streams out, all these streamers come out here. I'm not going to get into that, it's not important. But I am going to show this now. So we're already up to about 500 volts without even really doing much to that. Now this is not the efficient way of doing it, this is just an illustration. So I want to watch this that it doesn't go above the voltage of the capacitor and blow it out. Whoops. So right now we're at 4,000 volts. I almost went overboard. So we gotta be careful there. Yeah, we're at 4,000 volts. Now this is gonna be a big pop here. I should use a resistor and slowly drain it. Oh! It's always kind of scary. Should have probably disconnected my voltmeter when I did that. It went way negative there. So now it's disconnected, or it's discharged. But you can see we can rapidly charge up capacitors, and this is a big capacitor, and this is just one. So if we stack this, we get more, and that's what's all in Don Smith's presentation, and it's kind of self-evident when you think about it. If that's the way the energy is flowing and we're capturing it in a dipole, then it'll work. So where am I going to? I'm going to a floating ground here. So this is, or not floating, this is, yeah, I mean this is an air ground I should say. So here's a fluorescent bulb. We should be able to light this up. Not sure how good that wire is. Yeah, it's lighting up. So let's turn off some lights here. I'm gonna watch my voltage. I don't want to blow up that expensive capacitor. So let's turn out some lights here and look at this for a minute. Now I gotta see where I'm going. So I've got that fluorescent tube on there. I'm going to find the power switch. Oops. So you can see if I directly connect to the metal or the ball, or just kind of the area of it. So which way is the flow? Right? So I better not try and charge up my capacitor too much more. Oh wait, let's run, before I forget, let's run the bulb. This is the one that you put in your hair. Whenever I've had headaches, I put this in my hair. So that's why I call it violet ray. It's not ultraviolet, it's a violet ray. Now I don't recommend doing any of these things for any period of time because it's actually dangerous for you. It's actually these high frequency devices. You know, that's why I use this zinc box down here. I've got, there's a lid for it anyway. Because really, once you get this all figured out, you use all the appropriate things. Oh wow, we're over 5,000 volts now. That's not good. So let's discharge that kaboom. Yikes. This is going to be a big smack. Wow. Yeah, that's not good. To over stress my capacitor. See, that's still not even discharged. Oh wow, it did. So anyway, what I'm saying is, you want to be very careful. This is one reason why I haven't really gotten into this too much, because I don't want people playing around and hurting themselves. You can kill yourself with even like a high voltage cap like that. It's like, it's what you have in the defibrillator, same kind of concept. So while it can bring people back, it can also send people down, you know. So let's look at one of the dipoles he uses was a, not a fluorescent tube, but a, what do you call it, a big ball. Well, not a ball, I got a ball over here, a plasma ball, but a plasma tube, a column, which the only place I can find them here is in the States. It's like $4,000 or something like that. It's crazy. And you can get them from Conrad in Germany, but they won't ship to Canada, US because of liability insurance. Apparently we sue people here, so they don't refuse to ship to us. But you can use a plasma tube, and what it is you're sending a very high frequency pulse back and forth, right? And every time it's energizing this capacitor and you're running a load off of it. So the faster you go, the more you get out of it, the more plates you stack. And so the key thing is, you can still run your load. So I was talking to an associate of mine the other day, and we were talking about how many different types of energy production you can create. So say, if we go back to Daniel McFarlane Cook, the first free energy patent like I showed, he already talked about these things 150 years ago. Well, almost 150 years ago, 1871. He said he would have his improvement upon induction coils, which this is an induction coil right here with the interrupter. And he was talking about running it as a motor and an oscillator. It was a battery, actually. It was a mechanical battery. Anyway, So you could create, what I'm trying to say long-windedly here is that the process that you're doing in this tube or this dipole is independent of this collection in this capacitor. So in other words, it's not affected by it, essentially, or it need not be. So in other words, you could still make this into a motor and drive a motor, which I do with my motors now. We have made the motors with the Adreno that we have the frequency, like 3 frequencies with all together. The on-time frequency, in that frequency we have the high pulsing, and then within that frequency also we have the Liberty pulse, which is disrupting the frequency pattern every 10th of a second, so that biologically it's safer. Another whole story, as I talked about before. So I can run this as a motor, completely independent of running it as collecting more of the Heaviside component flow, right? So we're not just diverging it here, but we're actually collecting at right angles, right? Secondly, like I said, I can multiply this out, boom, 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 because I'm not doing a transformer action here at all. It's independent. And so then, from there, we can create heat at the same time in our motor, and then also with the circuit part of it, we can charge another battery. So we can run a load, mechanical load, which we could convert to more electric. We can create heat. We can create light. This light all around here could be lit up, these gas tubes. And then we could charge more output with collecting that and charge a battery while we're driving the circuit. So, I mean, it's fun. It's amazing all the different things that you can do. But why is it that people aren't doing that? I have no idea. Because they're arguing themselves out of it. They don't get around to doing it. Whatever. I don't know. So, what else is there to say here? Yeah, like if you're going to do this stuff, you have to, I really should have been a better example here. I should have had like rubber gloves on and everything. Like I do have high voltage wires here at least. And these weren't high voltage wires though. And this is a high voltage bridge, which is nicer than trying to put these diodes together. Anyway, you shouldn't really play around with this. I'm demonstrating it. I know what I'm doing. At least I hope I do. And then what you should do is be placing these things into a suitable Faraday cage, like I have with the zinc. And then doing things remotely, testing them out, taking the time, especially in the area of possibly touching these leads that are still charged. You gotta get into proper habits before you start doing this. There's no forgiveness here, people. This is it's dangerous, and the ozone effect too is not good to breathe in, and just the X-rays that you can get from spark gaps. So this is one reason why I haven't taught on this. But I want to teach on the idea and explain that we're already doing this in the motors on a low frequency, low voltage level, which is a lot safer, and that's why we focused on that for years. But I figure I'd start teaching on this a little bit. And so maybe a little word about Don Smith, and I don't know, I didn't know him personally. I do know somebody who knew him fairly well. I knew a couple people that knew him, and I can't, confirm his character or business relationships or anything about that. All I have is what he's presented in his book, which I have here, and on magnetic resonance processes, and also in his videos. And what I have been amazed to find out is that there's a whole bunch of forums online that are I can't explain why they're not succeeding in replicating his particular systems or understanding this, what I'm talking about today, but instead going off into all these different directions and essentially saying that it's not possible or whatever. It seems to be a big campaign to try and make people not believe this is possible. And so I encourage people to pay attention to the details and just not believe all that nonsense. And I'll say that what I did, instead of going directly to the Don Smith system, which is really, 80 years after the fact, go to Benita's. Look at what I've shown with the Benita's systems, and you'll see the last patent by Benita's was essentially what Don Smith was doing, and Ed Gray and others, and Tesla was doing these sort of things as well. So go to Benita's with the induction coil, and understand, do it easy enough, and then you'll know that this system, Don Smith knew what he was talking about, and as far as I know, wasn't faking it. I can tell, I talk to all these types of people who are watching this video all the time, thousands of people over the years. I know when somebody knows something and somebody doesn't, and that man did, by all appearances. What he teaches here is right. Now, it may not be totally right in the sense that some of his theory, his electron theory and all that, I don't know if that's correct or not. But the general teaching, the processes all make sense. So again, be careful who you listen to, and go read the original materials, like I pointed out today. Go back and carefully look at the words as they define them. The people who actually did these things, who were the first players. Find out why somebody, like something where the first occurrences happened, the first time things were defined a certain way. Like you have to say it says who. You have to find out. Ask yourself the question, is this really an authority? And really question things. And that's what I'm trying to do in all this. I'm not an authority by any means. I'm just really a hobbyist myself, and just trying to help out where I can. But I want to actually try and help people not waste their money, their time, and their faith on going around in circles. Like, number one thing that just keeps coming back to me again and again is people call me up or email me or whatever. I meet them and they say, well, where do I begin? What do I've been at this for 15 years and they still haven't succeeded. And I asked them, well, I went out here and I went out there, and they got seduced by all these trolls on the internet who are not even trolls. Like, there's several different people. There are people who are trying to con you and sell you something that doesn't even work. There are people who are mistaken. They think they have something and it doesn't work. Or it works, but it doesn't give them any beneficial results. Then you got these people who have all this information and they've got websites set up, and for years they're showing all these things, but when you ask them, they tell you they've actually never accomplished anything. Like nothing has actually been proven out. And you're like, well, what's the point? Why did you have this website up for all these years? It's like, I don't get it. And then you get the people who are actually successful, you don't see them on the internet. You might see a passing word from them or whatever, but they don't bother with McChatterland. So I would be very careful going to all these forums. Go to the people who have actually done something. Go back to the originals, like I've tried to show. Start from there. And then once you have something, like I was showing with these motors, you see that, okay, let's look at that for a second. So you got a motor, right? It's being run by a battery, right? It takes so much power. So say it takes 100 units of power, 100 units to charge this battery up, to perform 100 units of work. The battery will be discharged and the motor will have run. Let's look at 100, right? Just use the word 100. So now it takes that many units. So now if I change the circuit on this motor and I am charging this battery so that I can go like this, and when this is discharged, this is charged, and I charge this up. Well, ask yourself, well, let's say 150 units. It takes 150 units to charge this battery, and it only gives out 100 units. That's much more correct. Because you have your losses in your battery charging, your losses in your motor, the transmission from the battery to the motor, the self-discharging the battery over time. So let's say for 100 units of power, it takes 150 units to charge the battery up. This is typical, right? But now, I'm charging this battery at the rate that this is discharging. So if it takes 150 units to charge up this battery, and I'm only getting 100 units, it's taking 100, it's only giving out 100 units to run this motor, but yet I'm charging this battery up and I'm able to rotate it around. Is that 100% or is that far more? That's what you got to realize. So if you only get 10 units of power in this battery while you're running this motor, that would be great. But nobody gets that low results. So if you got 50 units, then you'd be doing pretty good, right? What about 75? What about 90 units? Some people maybe get 95 because they're using really small batteries and they're junk batteries or what have you. And then they say, well, Rick, eventually it went down after a couple of weeks or a couple of days, or, the battery eventually discharged. So I said, well, let's look at your batteries. What kind of batteries do you have? Well, they were sitting in the garage for 2 years, Rick, or I bought them, they were brand new. I said, well, how long did they sit on the shelf at the store? Look at the date stamp on it. Oh, you know what? They were actually a year old when I looked at it, Rick. Can't believe it. You're right. Well, the batteries need to be rejuvenated. That will take some time to rejuvenate them. So, okay, we'll try now and charge up batteries, like 4 of them, in series or parallel. Now see what you get out of it. Suddenly, I'm getting 200 units or 150 units or no, we already say 150 units would be swapping around. Now I'm getting like 200 or 300 units of energy when I'm multiplying my batteries out. Wow. Well, in order to rotate these batteries around, we've got to do another little process with the capacitor, and that's another whole story. But what I'm saying is, let's really calculate out things here. And we've got to really count all these factors in. And let's be fair about it. And let's not be overly critical about the most basic process. Now we can add to it, like I said, the second stage process, the third stage process, and so forth. But like I'm trying to do is create awareness. This is a very simple thing to show. If you understand how the energy works, or if you bother to pay attention to it, and you don't want to try and, you can't do a 5-minute experiment, people. You got to commit the time to really understand what you're doing. And so that's what I'm trying to do with these videos. I'm saying that what I'm saying is not something that some kooky person made up. You know, we're talking about the founders of this science. We're talking about going back to these major players. What did they say? What did they admit? What did they discard? Why did they discard it? What have people been doing over the years? And what I hope to show maybe is the various products that you've had in your possession. Pretty well everyone in the first world lifestyle countries have been using different devices over the last 50, 60 years or more that are over unity devices. They haven't even realized that. So what I'm trying to say is, and it says almost anything can be if you know how to collect the energy, as Bearden talked about. You know, you have to learn how to collect it at right angles. And so now think about, this is a capacitor, and think about a coil. I don't have one that I can just pull out here. So when we think about our coil in different configurations, and not just simply deal with induction, but tap into this in the right way. A coil and a capacitor are interchangeable. They both have inductance and capacitance. And so you can collect this energy in various ways. So really, there's not much more to say about that. This is about as far as I'm going to go with this, because I really am not going to cross the line of, I mean, I guess I've crossed some lines already, but what I'm saying is, this is the basics of it. This is all you need. There's nothing more than what I've shown today. It's relatively inexpensive to do, and I'm not going to get into any more advanced stuff online. You know, it's all for private knowledge and private use. I'm pointing you in the right direction, the right materials to look at, and you can figure out the rest. So I hope that is satisfactory and helpful, and like I said, be open and don't waste your time. Ask yourself, says who? Somebody's trying to discredit somebody, don't just believe it. You know, suspend your judgment, be careful. And like I said, go to the source, find out for yourself, and get the information while you can, you know, because as I was talking to a friend yesterday, you know, a lot of these old websites are gone. You can still find them on the Wayback, but there's a lot of information that has been changed, like the Patrick Kelly Free Energy book is is the distortion of the inventors that he represents there. He changes the words, and he doesn't essentially know what he's doing. So you got to watch out for these kind of misinformation. People who claim to know certain people or processes, and then so you fall into it. Oh, they're the expert. Oh, but they were never able to succeed. Well, therefore, it's not true. Oh, that's what psychologically is a trick. You fall into that trap. So don't believe that. Check it out. And don't believe me. I'm just providing things that you can verify for yourself. And I'm not showing this as the correct way of doing it. This was just a very simple, quick thing that I threw together in 5 minutes to just do it. I'm not going to show you this system running, ever. Now what I will do is provide several kits coming up that are the very basic introductory level of this, where you can see a little bit, and then you're off on your own from that point. And so we will have the little resonant kit coming up, just showing you the basics of resonance power transformation. And then we'll show a little Benita's setup. I'll probably have two different, for the 2 different patents, 2 different kits. And you can expand upon them. You can do whatever, but we'll do a little one on that side, but I'm not going to do a big system for various reasons. And like, I don't want people to hurt themselves primarily. So anyway, that's what I'm going to say, and thank you for watching.